Continuing 9.5, hazardous weather and geographic regions at risk. There are several stages in thunderstorm development and dissipation. The first stage is the developing stage or cumulus stage, when moisture supply and updrafts continue and clouds grow. There is a continuous release of latent heat from condensation that warms the surrounding air, causing the air to rise further. The cloud expands into colder air, causes water droplets to freeze. Larger snowflakes fall and melt as raindrops, while large droplets grow until they cannot be supported by updrafts. The second thunderstorm stage is the mature stage. Downdrafts and falling precipitation leave the base of the cloud. Both updrafts and downdrafts are present, and the cloud continues to grow until it reaches the top of unstable atmosphere, possibly the tropopause. At this stage, the storm generally produces heavy rain, lightning, and thunder, and occasionally hail. The third and final stage of a thunderstorm is the dissipative stage, or dissipative stage. The upward supply of moist air is blocked by downdrafts. The thunderstorm weakens, precipitation decreases, and the cloud dissipates. And everything returns to sunshine and rainbows. Ah. Most thunderstorms do little damage, though they may be scary for your kids and dogs. Here is a cartoon summarizing each stage. First, on the left, we have the developing or cumulus stage. You see the warm, moist air updrafts depicted with the red arrows. As the warm, moist air rises, it cools and the moisture condenses, forming the cloud. You can see that the cloud altitude is not very high, perhaps 7 kilometers at the top. In the middle, we have the next stage, the mature stage. We have strong updrafts of the warm, moist air depicted in red arrows, and strong downdrafts of cooler air depicted in the blue arrows. The top of the cloud approaches or reaches the top of the troposphere, the tropopause, with an altitude of more than 12 kilometers. And the third stage, the dissipative stage, is depicted on the right side. The downdrafts take over, shown in the blue arrows. They are weaker than in the mature stage, as the updrafts are no longer whooshing the warm air out of the way. Another way to think about it is that the pressure increases. The cloud also begins to dissipate a bit, as it also needs the warm, moist air updrafts for condensation to occur. As the precipitation also ends, sometimes abruptly, and sometimes more gradually. The National Weather Service classifies a thunderstorm as severe if there are winds greater than 93 kilometers per hour, i.e. 58 miles per hour, or there are hailstones greater than 1.9 centimeters, i.e. 0.75 inches in diameter, or a tornado was generated. I agree. Any of those conditions would constitute a severe thunderstorm. I might even be a little less exacting than the National Weather Service. And necessary conditions for a severe thunderstorm include large changes in vertical wind shear, meaning differences in wind speed and/or direction. The greater the wind speed, the more severe the storm, and the more likely a tornado will form. Necessary conditions for a severe thunderstorm also include high water vapor content in lower atmosphere. We need that warm, moist air. And updraft of air. We need that warm, moist air to rise fairly quickly into higher, cooler altitudes. And we need a dry air mass above a moist air mass, which helps establish strong downdrafts. There are several types of severe thunderstorms. One type is a mesoscale convective system, MCS. They are the most common type. They are very large clusters of self-propagating storms in which downdrafts from one creates a new storm, forcing warm, moist air aloft. Downdrafts come together to form outflow boundaries, which are curved lines of thunderstorms that may travel long distances. The weather map below shows two curved lines of thunderstorms that span several states. I can see Oklahoma, Texas, Arkansas, and Louisiana getting pelted with rain, perhaps even hail. This type of severe thunderstorm can last a fairly long time, on the order of half a day. Another type of severe thunderstorm is a squall line. These are long lines of individual storm cells, common along cold fronts. Updrafts form anvil-shaped clouds, extend ahead of the line, and downdrafts surge forward as a gust front in advance of precipitation. These types of storms can develop along dry lines, i.e. fronts with differing moisture content but perhaps have similar temperatures. The weather map shows a squall line stretching from Oklahoma up to the Great Lakes region. The Midwest shows large, severe thunderstorms very well. So, little thought quiz. We have moist air and dry air. Which air will form the updrafts? Moist, of course. Which air will form the downdrafts? Dry air, of course. Okay, so which air will have a lower pressure? Moist air. It is lighter after all. Remember, water vapor is lighter than the nitrogen molecule or the oxygen molecule. So, which air will have the higher pressure? The dry air. Yay, I hope you got it. Next type of severe thunderstorm, the supercell. They are smaller than mesoscale convective systems and squall lines, but more damaging. They are extremely violent and spawn most tornadoes and generally last only a short time, 2 to 4 hours. The weather map shows a supercell with its distinctive curlicue. Part of the supercell development is a mesocyclone, where there is a spiraling updraft of warm air. Downbursts from thunderstorms can create derechos, which are strong, straight-lined windstorms with wind gusts that can be tornado strength. They are at least 400 kilometers long. Derechos can cause fallen trees, power outages, injuries, and even fatalities as winds often exceed 90 miles per hour. Derechos would be pretty hard to outrun or outdrive. The picture is of a derecho that has a lot of dust in it, which makes it easier to see. Microbursts are much smaller than derechos, but also originate from downbursts from thunderstorms. They are particularly hazardous for aviation as they are smaller and harder to detect, and hard to compensate for once you fly into one. As microbursts are smaller, they are more common than derechos. Remember that inverse relationship between magnitude and frequency. Hail is hard. Round, irregular pieces of ice originating from thunderstorms. They contain rings due to adding coatings during updrafts. Hail moves up and down and up and down in the lower part of the storm, adding layers of liquid water, which then freeze. Hail mostly causes property damage and only the occasional death. One of the largest hail in the United States fell on June 2003 in Nebraska. It was as large as a volleyball, 7 inches in diameter, 1.7 pounds, and hit the ground at 100 miles per hour. The largest official hailstone ever collected in the United States is an 8-inch monster that fell in Vivian, South Dakota on July 23, 2010. The bottom image is an image of that largest hailstone. The top and middle images are of hailstone cross-sections, showing us the nice concentric rings from those many layers of ice added as the hailstone went up and down in the cloud a bunch of times. Like an onion, but inorganic, and will only make you cry if it hits you. On to tornadoes. They are usually spawned by severe thunderstorms, supercells in fact, and they are deadly. From 1992 to 2012, 62 people were killed per year due to tornadoes. Tornadoes are defined by a vortex extending downward from the cloud and touching the ground. They are called funnel clouds when they do not touch the ground. They form where there are large differences in atmospheric pressure over short distances. Top image is of a tornado, and bottom image is of a funnel cloud. There are several stages of tornado development. The first one is the organizational stage. In this stage, vertical wind shear causes rotation to develop within the storm. Strong updrafts in advance of the front tilt the horizontally rotating air vertically, which we know is known as a mesocyclone. Downdrafts at rear of the storm lower part of the cloud, called a wall cloud. As the wall cloud rotates and the funnel descends, a tornado forms as debris on the ground begins to swirl beneath it. Note, tornadoes can form without wall clouds or mesocyclones. And wall clouds and mesocyclones don't always form tornadoes, but they are good indicators. The image is of a wall cloud and a tornado near College Park, Maryland, September 24th, 2001. The tornado remained on the ground for 17.5 miles as it moved northeast through College Park, Bettsville, and Laurel, Maryland. Source: Washington Weather, according to the Washington Post. This image is of a wall cloud seen on a storm that eventually produced tornadoes in Kansas on May 25, 2012. Photo by CWG photographer Ian Livingston. Taken from the Washington Post again. Here's our cartoon showing the organizational stage of a tornado in A and B. Part A shows the vertical wind shear causing rotation. Part B shows the updraft tilting the rotating wind. You can imagine a downdraft helping as well once a downdraft is established. Part C shows us the mature stage, which we are covering next, with the mesocyclone and tornado fully developed. Tornado development, mature stage. Visible condensation funnel extends to the ground. Moist air is drawn upward. In stronger tornadoes, smaller whirls may develop within tornado called suction vortices, which are responsible for the greatest damage. The top image is of a tornado again, and the bottom cartoon shows several suction vortices twirling around the tornado center. Suction vortices continued because they are so destructive. Here's a quote from NOAA.gov. Multiple vortex tornado. Many tornadoes contain smaller, rapidly spinning whirls known as subvortices or suction vortices, but they are not always as clearly visible as in this big tornado near Altus, Oklahoma on 11th May 1982. The suction vortices can add over 100 miles per hour to the ground relative wind in a tornado circulation. As a result, they are responsible for most, if not all, cases where narrow arcs of extreme destruction lie right next to weak damage within tornado paths. Subvortices usually occur in groups of 2 to 5 at once, the 6 or 7 evident here being uncommon, and usually last less than a minute each. Tornado scientists now believe that most reports of several tornadoes at once from news accounts from the early 20th century tornado tales actually were multi-vortex tornadoes. However, on rare occasions, separate tornadoes can form close to one another as satellite tornadoes.